Okay, ma'am. Live, ma'am.
Okay, sir. Good afternoon. Welcome, everyone. Thank you for joining us on today's webinar. The topic is Industrial IT, Industrial Operation, and it will be decoded by our impressive resource personality, Mr. Arun Madhan Sermakasi from Integrella Private Limited, London. I am welcoming you all on behalf of Department of Computer Science and Engineering as a part of Nadar Saraswati College of Engineering Technology, TENI. Now, without further ado, we will turn the time over to call Mr. P.G. Shivasharma Karthik, Assistant Professor, CSE, to give away the garland of welcome address. Sir, over to you, sir.
Thank you, ma'am. Good afternoon to one and all. Nowadays, e-learning is a new passion and have been trending for us to develop our career and for the job opportunities during this COVID-19 pandemic situation. First of all, I feel very elated in thanking our management, Teni Melapete Hindu Nadargal Guravan Murai, our Secretary Sir, Mr. K.S. Kasi Prabhu, and Joint Secretary Sir, Mr. A. Rajkumar, for providing us this wonderful opportunity on successful gathering of this webinar. Next, I welcome our Honorable Principal Sir, Dr. C. Madhalai Sundaram, for his guidance and wonderful support for organizing this webinar. I hope this technology is very increasing very rapidly and vastly, and that too in the extreme speed of correlating IT and automation. I hope this is the time for all of us to learn more about information technology and its complete dissemination. I welcome our chief patron of this webinar, the resource person, Mr. Arun Madhan Sermakasi from Integrella Private Limited, London. And also I extend my warm welcome to our vice principals, Dr. A. Soleraj sir and Mr. N. Madhavan sir, placement officer, industrialists, my professional teachers from inside and outside of our college, and the students from our institution and all over the India. And I welcome all and all for this webinar. Thanks for this opportunity you have given. I don't want to waste this precious time in welcoming. Let me conclude this welcome speech. Over to you, ma'am. Thank you.
Okay, sir. An hour will not be enough to welcome our resource person. Without further delay, let us welcome Mr. Arun Madhan Sermakasi. He has 13 years of experience in software analysis. His technical skills are very strong in environments such as programming languages, technologies, database, middleware concepts, middleware tools, used domain knowledge. He has undergone various projects from UK, Mumbai, Bangalore, Sweden, Hyderabad, and Chennai. In short and sweet, we feel honored in welcoming the most successful and talented person, Mr. Arun Madhan Sermakasi. And now it's time to hand over the session to resource person who expertise on subject matter. And also, I request to make this opportunity to be a fruitful one. Okay. An important note to the participant is that if you have any intellectual queries during this webinar, you can type them in the chat box after the resource person talk. Sir, over to you, sir.
Thank you very much. Hi, everyone. I'm really delighted to meet you all in this medium. First of all, thanks a lot for the college management and the staff member who have arranged such a wonderful event. It's all digital and the information is available real time these days. So it's really happy that during this challenging times, we are sticking to our responsibility and keeping up to date with our knowledge. I'm really happy to share whatever information and knowledge I have over this presentation. We will go over some of the leading trends in the IT industry. We will clear out some basic challenges and questions that you all have in your mind that you haven't asked so far. We will also see how the IT industry functions, because right from the day one, when you're dropped into an IT company, it's almost like landing in an ocean that it's very difficult to identify north or south or east or west over there. So we will go over that, how the company functions, how the industry gets the projects, how the business happens, what's the leading trends, uh, and various other stuff. We will also have a 10 to 15 minutes questionnaire session at the end. I'll try my best to give more time to that, because I would be really happy to answer more questions from coming from your side. So yeah, let's not waste any more time, and then we'll jump into the slides. So we are here currently to disseminate and study more about IT industrial operations. Little intro about myself. I'm pretty sure, like, I'm impressed with the introduction given about me. Thanks for that. First of all, I just wanted to check, like, is everyone able to see my screen and my presentation?
Yes, sir.
Yeah, that's great. So yeah, like the management said, like, my name is Arun. I graduated from PSNA in Dindikal. You must have heard about this college, and I'm one of the student of the college affiliated to Anna University. Currently, I'm working as a technical architect in the company called Integrella. We are based at London, and I've been in this industry for 13 years, have worked across multiple other companies in India so far. Tech Mahindra and Computer Science Corporation is one of the pinnacle ones that I would like to mention. And currently I'm leading the digital integration team, and we are going to talk more about what is digital integration itself here. We as a company, Integrella, we specialize in various domains: financial, healthcare, public sector, retail, and some of the worthy customers that we would like to mention, or the hospitals and the government trusts over there. Right. So as an agenda, what are we going to see today? We are actually going to go over IT business model. We are going to see how the IT business functions, the team structure, the various people, how a particular team in an IT industry looks like, so that you guys can visualize where you guys fit in when you are hired by a IT company. The procurement process is how IT company gets business or projects into it. Then we are going to see something about development model. Like, you must have definitely gone through development model as a part of your syllabus, but we are going to see a bit more with some realistic examples. We are also going to clear out some doubts about HTTP, HTTPS, because this is actually the core of everything that we are going to learn today. Everyone knows that cloud strategy and cloud computing is actually the trend these days. More than using cloud for storing your emails or Google Drives or OneDrive or whatever, like, but we are going to see, like, what are all the different strategy and types the cloud computing offers in this modern IT world. Then we are going to see digital integration. This is actually the hot piece that's going on now, and we are going to see, like, how IT has moved into digital integration, how IT has evolved there. And we are going to see something about APIs, application programming interface. We've always been talking about APIs for the past 30-40 years, but APIs has revolutionized digital integration these days. So we are going to see how what is REST API and how best we can secure this, because it's all internet now, and we have everything in web now. So without security, it's just the doors are open for anyone to enter and access the information. So security is a very important thing here. So we are going to see about types of security, the multiple flavors, how best you can actually secure your apps and or website, whatever you're building. OAuth is one of the favorite security mechanism we are actually using. We've been using. I'm sure you all have used OAuth in either one of the websites you have used in your life. So we are going to see everything that we are going to learn today. We are going to relate it with a real-time application you have used at least once in your life, so that you will be able to visualize. After this session, I want everyone to go out and look at the websites and applications around you and visualize them in terms of specifications and designs. So then it will be easy when you guys go back to your books and study the definitions and concepts. So let's get started. Let's get to know, like, what is IT business, like what happens inside the industry. Generally, any company, large or small, they work for themselves or they work for someone else, they only do 3 type of business: application development, maintenance, and support. It all comes down to just these 3. Application development is for anything that the team invents something new, like they develop new projects. They a customer approaches the company and says that I want such a website, I want such an application, I want a ticketing system booking, or I want an online banking system, or any specification. And then they listen to that. You build something for your college. Everything that you start from scratch and you deliver all comes under application development. These projects, they have a fixed budget, because when you start this, you get into an agreement that you will finish this within 1 month or 2 months, or either it is about duration or it is about money that you will finish within a particular budget. So there is a tight deadline, and you need to stick to that in terms of cost and in terms of time. Anything you spend more than that, you take more time or you take more money to finish that, then it is a loss for the company. So the pressure is always high. And then but the advantage is that since you're starting something new, you can always study the latest technology, the latest language, the latest database in the current IT industry, and you can actually implement them. So people in the team will really have the advantage of using what is best in the market. And it's just a tight deadline that keeps the team together. So new applications, websites, products, data analytic engines, whatever that you build new for someone or for yourself, comes under this development. So there is always a chance for rapid innovation over here. Application maintenance, I would say this is more like someone has developed something and you go and give a commitment that okay, I will take the responsibility of maintaining this. So there is a slight difference between maintenance and support. Most of the companies, they do this together. Some companies, they undertake maintenance and the support is given to a separate team. Maintenance is more like when you have taken responsibility of a project which was done by some other company, maybe 2 or 3 years ago. You realize that something is broken, like you do a online transfer and then it fails within a particular time, and it fails only for Visa cards, it works for MasterCard. So this is some defect or a problem that you identify in that particular software. Then you are called by someone, maybe your customer, who calls and says that online transfers doesn't work for a particular card or particular account. Then you receive a change request, so which is more like a fix. So you have to change only that particular point. So you are actually, what you're doing is that it's more like repairing the punctures in your bicycle, right? So you are applying patches here and there, and you are keeping that system together. So you don't want that to crumble and break. So that's a maintenance. The challenge here is that it might be an application done by someone in the past, maybe 3 years ago, 4 years ago, or 10 years ago. It might be an old technology which no one knows. It might be a language that is not in the picture anymore. So there is a challenge that you need to keep your core team together. Even when one or two guys leave or switch, it's going to affect the stability of the team. So so application maintenance is more like the deadlines are a bit short, because you need to fix something within 2 days or 3 days, so there is a very limited time. So this is more like a team for people who have more experience, so that they can study the project within a stipulated amount of time, and they can actually, come up with a fix within matter of hours. So maintaining legacy servers, maintaining old applications, old products, websites, all come under application maintenance. Application support is very closely related to application maintenance, but it is only in terms of, maintaining the customer relationship, so that you leverage the complaints and the incidents that come from customers. So it's almost like you talk to a Airtel or any mobile provider customer care every day. You raise a complaint. If it is something that is related to a technical issue, then it gets escalated to the next team, who fall under the maintenance team, who come to your house or to come to the locality and provide a fix. So so maintenance and support, they actually work hand in hand. And in some companies, when the application development finishes, the team passes the project to the application maintenance and support team. So during that phase, they try to teach the team about how they have developed the project, what is the requirements, what are all the workflows, how this will be, uh, what are the chances that it might break and where it could break, so that the maintenance and support team have the information to uh, you know provide 24/7 availability of the project, and also answer the questions raised by the customers. So when an engineering graduate is hired into an IT company, he's put under through multiple trainings based on different language, softwares, database, programming language, or new concepts, and after that you get branched out to these three projects based on the availability, whether development, maintenance, and support. Right. We saw about the IT business model, but we also need to know how the team structure looks like here. When it comes to a team structure, when the company is small, you have very less number of people, and then you report to the boss, who is just several layers above you. But when the team or the company is huge, you have multiple people, multiple designations, and there are too many people that you report to, and then that's when the designations gets leveraged. The reason we have to maintain a core team structure is we don't want everyone doing everything in the company, and we don't want people to people's responsibility to cross. So you don't want your lecturer to do your HOD's job, or you don't want HOD's job to do a lecturer's job. So it's just to make each other's life better, so that the responsibilities are shared, so everyone focus on their work, and then that comes out as a betterment for the company. So in any company, when you look from the top to down approach, the head of the company is always the executive board. So it could be a CEO in smaller companies, but depending on the size of the companies, it could be split across a CEO or a CTO or a COO, based on whether he's going to bring new technology. Then it comes down to a chief technology officer, then or an operating officer, or an executive officer. But in middle or small level companies, these are all clubbed into a single person, who would be a CEO, who takes the executive decisions of all the members in the company. Then comes the sales team. They are the responsible team who has the contacts with the clients. Their only job is to maintain their communication with the external clients, talk more about the company and what they have done in the past, and bring more projects. and try to lure them into attractive deals and provide more quotations and conduct more workshops where they can actually exhibit their business. So it's more like a relationship team who takes the business to the company. And next comes the senior level management. So again, based on the size of the company, there will be a different managers here. Like I'm only categorized 3 managers here, or 3 type of managers here, I would say, but there are many more based on the size and the construction of the company is concerned. So a delivery manager, release manager, offshore manager, they are not I would say they are not directly managing the team. They are the managing the team that manages another team. So they have a senior level view of what's happening under them, uh, where the actual core team does the job. That's where the team highlighted in the golden boxes. So they form the core team of any company. The dev team, which starts from the ASE, or few companies hire at the level of associate software engineer, few companies hire at the level of software engineer. So it's based on with the size of the company again. And then you get on to the senior software engineer position, ATL, associate tech lead, then the tech lead. Then you get into either a scrum management or project lead, QA, which is the testing side, senior quality analyst, lead quality analyst, and then a project manager and a test manager. So these is actually the core part of any company who actually does and delivers the job. Then they are managed by the senior management, who has direct relationship with the sales, and sales brings the business through the clients. That's how it works. And where the architect come into picture is that the architects, they are 3 types: technical, solution, and enterprise. um, in again, like for mid-level and small level companies, these 3 can be clubbed into a single position usually, but there is very much difference between technical architect and a solution architect and an enterprise architect. Technical architect is mostly closely related with the core team, rather than with the sales team and the senior management team. So their job is to get the work, and then split them, design them, and then we're going to talk more about how to design a work, and then we are going to talk more about what is a technical architect and how a technical architect solution looks like. We're going to see in the further slides. But the solution architect is more like one level above technical architect. He won't talk. He's going to talk only about the solution, and he's going to talk more about which tools and which technologies and which language we are going to use, and how the broad solution for a particular requirement looks like, and things like that. An enterprise architect is going to think from a business perspective, like if they have a brand and what they deliver, they're going to dictate a bit higher level above the solution architect itself. So it's more like enterprise architect feeds his output into the solution architect world, where technical architect can pick up from solution architect and provide the work to the core team, which will be splitted across to multiple people, which will be used for development and delivery. Then comes the HR and admin team. So they are the team that doesn't have any client interaction compared to everyone else in the company. But they, again, I mean, there's too many departments under HR and admin team, but usually they take care of the payroll, your salary, your other legal matters within the company, and any other admin or logistics like your cab services, or anything that is non IT functional that happens inside the company comes under HR and admin team. But they are generally called as HR and admin team, but they have different other classification, and they have a better dilution among themselves. So now that we know how a typical IT team looks like, and how you guys might fit in based on what you graduate and how you skill up and what experience you gather, let's see how the big business comes inside the company, right? This is one gray area, right? Like, because we join the company, we are given work by the project manager or your TL. We do the daily job, we deliver, and then we go home. But we want to know, like, how this happens, like how we are getting the project, like what are all the steps involved. And when you grow in your company from a software engineer to a senior and a lead and a project manager, how different are your roles compared to what you're going to do today, in maybe in 3 years or 4 years. This can give you a better mental vision so that you can actually be prepared for what is going to come in the future. So when it comes to procurement, everything starts with actually the sales team. So the sales team always has a way to maintain records of their client pool. So client pool is actually the list of clients or the possible vendors who have a requirement in the current market. So it could be a bank who needs a new online banking website, or they need a new mobile app for their mobile phones, your Android or iPhones platforms, or it could be a hospital because we are trying to reduce paper usages everywhere. So we want to automate everything and make it software driven everywhere. Or it could be a store where you go and purchase your cloth, you get billed by your the computer at the reception there, or you order through online like Amazon and you get it delivered to your home. So it could be anything. So but it's all based on the relationship, or they hold any workshops displaying the potential the talents in the company and their previous records that they have achieved. So when they initially talk to the customers, the few questions asked are, what is that you want to be done? So the client says that I need a website, or I need an app, or I need a program, software, whatever. He gives the specifications of that, and the sales team has to visualize that in terms of size, volume, and cost. So how much money that would bring to the company if we work for that project, how big that would be. Would it take 30 days? Would it take 60 days to finish it? Would I need say 4 guys to finish it, or would I need 10 people team? Do I need 2 managers or 1 managers to need? So all these questions runs in mind, and they have to respond it with a quote. So it's more like a tender that you normally see in the real world, that sometimes the client might invite 4 or 5 companies and specify that this is the work I have in my mind. Can you please give me the estimated cost? And then whoever quotes the lowest cost wins the project. And but the sales team is a non-technical team. They don't have any idea about saying how many days will it take to complete this project, because they are more financial expert. They know how to do sales, and they know how to deal with money, but they are not IT experts, or they are not technological experts. So that's where the architects come into the picture, because the sales team, as soon as they get this information from the clients, they talk to the architects and business analysts. So these guys, business analysts know the domain. Business analysts are someone who knows how banking works, or someone who knows telecom works, someone who knows how healthcare works, hospitals run, or how railway systems run, what are all the concepts behind it. So they have a business analyst pool, and they have an architect pool. So architects know in and out of the technology. They know programming language, they know database, they know higher level, they know designing best practices. So these 2 guys, they play a crucial role when they get this specification information. So they translate that into design and estimate. So they have the knowledge to say that it will take 40 days to finish this project, and they provide the technical design to justify why it takes 40 days to finish this project. So when they say it takes 40 days, so they translate that into a cost. Say, for example, if I employ 4 people to finish this project for 40 days. So if a cost of one person is $500, then they calculate the cost for 4 people for 40 days, and that is the total cost of the project. And that is actually how they calculate the cost of the project, and they submit that as a quotation to the client. So if the quotation goes well, if the design went well, then what happens is that you acquire the project, the company wins the project. It all depends on the design being accurate, the estimation being accurate, and the cost being accurate. So when everything works together, then the company wins the project, and the project is given to the management team, who is formed by technical architect, project manager, and the scrum master. So we will see more about scrum master role and the project manager role in the further slide, but these guys form the responsible management team who will deliver the project after undertaking the rights to deliver the project. Technical architect is going to sit with the core team to help with the design. If the project deviates, or if any programmers make any mistake, if they don't understand the requirement, if they do it something that the client doesn't want, if the client wants a different screen with 4 buttons, if the programming team has created a screen with 6 buttons, then you have deviated from the requirement. So that those criteria are handled by the technical architect, and he makes sure that the project is in line with the client's requirement. So any doubts, they take it back to the client. They ask it, do you need the project to be like this? Do you need the screen to be like this? What do you want to happen if I press this button? So all these business related questions are raised with the clients, which comes back as a feedback. And finally, when the dev team and the test team have developed and tested the code, it is delivered or released to the customer. So this is actually the what happens when a company wins a project and what it does to deliver the project. I could see that people are raising your hands. I could see that you have many questions. So either I can actually stop in the midway and allocate 5 minutes for some of your questions, or I can actually stop totally at the end. But when I stop at the end for the questioning sessions, please make sure to tell me for which slide title that you have this question for. So that will be important to know about what we are talking about. Moving on. You guys might have learned more about the development methodology. I'm sure about second years. I'm not sure like if this has come as a subject for first year students. But development methodology is an approach or the procedure that you take to deliver a project to the customer. So waterfall is actually the most basic of all, and you always do waterfall for simplest projects where you know that you're not going to make any mistake at all in delivering it. For example, if someone has said, I need a mobile app basically that plays some music and access some music library. So you know the requirement, it takes just 10 days to finish this job. Then you collect the requirements, design the requirements, you design all your UI, you design what is the background color, how many screens you want in this app, do you want to provide a login screen and things like that. Once you have finalized the design, you give it to the development team, they develop all the screens, they develop the app, you publish it into the Android Play Store or Apple iStore. Then it gets tested. It gets tested in the mobile, it gets tested in as an app, then it gets deployed. And once it is deployed, there's no point to go back. When a customer says, okay, you might have missed a small screen, then but there's very less chance for you to go back and make amendments other than doing it again, or maybe releasing a bug fix, more like a version 1.1, right? or if you have actually made a mistake in assuming your requirements. You thought, okay, you might have to collect music from a cloud library, but the client wanted you to access his own library. He has collection of music in his system, which you did a mistake when you gathered the requirements, or the requirements were wrongly documented. Then there's no point in going back actually in waterfall projects. So it's one directional. So that's why we call it as a waterfall. So it's a very risky process, but waterfall is very simple. It doesn't complicate things. So we all usually adopt waterfall for very simple and small projects which has a definitive timeline. But the most famous one is agile. Agile is more like a repeated waterfall. It's an iterative waterfall. So you do requirement gathering, design, development, testing, and then you release something. Then you again do a requirement design. So you get into a several cycles of the same process. The advantage is that, for example, if the project takes 40 days to deliver 5 pages of your website, right? In a waterfall, till the end of 40 days, client doesn't get anything. It's a big bang delivery. At the end of 40 days, you deliver all the 5 web pages that you develop, right? But in an agile, you break it down into modules. So you break it down into 3 modules or whatever number of modules, and at the end of module, you deliver something to the customer. So at the end of the first release, you have delivered 2 pages and your website is live. So people can still use your website, and you have started the business. Then after 2 weeks, which is the second cycle or second sprint, then you release 2 more screens. Then at the end of the third cycle or the third sprint, you release 1 more screen. So you have released a definitive amount of work at the end of each sprint, and you had a continuous release, and you get the customer happy. Now, what happens as an advantage here is that at the end of the release one, you might have released two web pages for the customer, right? So you started working on the third and the fourth pages in your website, but that's when the customer says, okay, I saw the work that you released last time. Maybe there is a slight change in the second web page that you developed. I need the screen to be adjusted and the moved. So can you take that as a change from me? Then what you do is that you accommodate that review comments into the second cycle. So when you are releasing third and fourth web pages, you are also accommodating the changes given by the customer. So this gives a chance for the customer to convey the feedback or convey his changes to the requirements. So it's very flexible for the customer as well, and it's very flexible for the company as well. And if at some point at the second release, you have released 4 web pages, you still have 1 web page to develop, and you have also accommodated the changes given by the customer. Now, for some reason, the client says, okay, I ran out of money. That's it. It's enough. I don't need the last one. Let's stop the project here. So even when the project is stopped in the middle, you still have 4 web pages released to the customer, and the project is live. You have also fixed the bugs. You just have not developed the last web page, which the customer says that he doesn't want it anymore. So the project is still stable. You can't do this in waterfall. You can't stop it in the middle. You won't have a finished refined project. You won't have any chance to accommodate the changes from the customer as well. So that's why agile, like the name says, it's very agile and flexible, and it breaks down a big project into tiny substances, and you release a particular module every time at the end of the sprint. We will, in the coming slides, look at a real-time project that is floating around our eyes, and then we will see and discuss like how we are going to apply that into the real world. But before that, let's get into some basic stuff, like, because everything that we are going to talk now is based on internet. So when it comes to internet, and when you access something over internet, it's all HTTP, right? So what is this HTTP? We have written or we have learned so many definitions from the books. It all says it's a hypertext transfer protocol. But what is hypertext transfer protocol means? Because we need to break the definition to understand what it actually means. So if I have to break this word, I can break it into three pieces, like hypertext, transfer, and a protocol. Protocol word means procedure or rules. Someone says like, you have to follow this to achieve this. Studying 4 years to become an engineer is a procedure, right? So similarly, protocol means a procedure. And transfer, the word transfer means you're sending content from one place to another place. So it means that it is a protocol to send something from one place to another. So what is that something? It's a hypertext. So what is a hypertext? First of all, let's try to understand what is a text. Text is anything, like you read a newspaper, you type anything about you, your resume, your CV, that's a text. That's a random thing. You read something, that's a text. But what is a hypertext? Hypertext is a text that is connected to another text. So if you click on something, a link, then it takes you from one text to another text. That's a hypertext. So when you look at this example, let me bring a marker here. So when you look at this example, it says a guide for HTML beginners is here. So this word here is a link. When you click on this link, it is going to take you to another page, which will have more text, which will have beginner's instruction for HTML. So that's another page. So it takes from one text to another text. So that's why this is called a hypertext. So a protocol that defines how to transfer a hypertext from one place to another is called hypertext transfer protocol. So to write any text, you need a language, right? Like without a language, we cannot speak. So that's why we have HTML. We have hypertext markup language. But again, what does this word markup mean? Why do we need? Why can't we just say hypertext language? Markup language is not a regular language. In regular language, whatever you speak, it means something, right? Like if I say like today it's going to rain, the whole sentence makes sense, right? But in a markup language, you see the content here in the first rectangle. Everything that is written there is not displayed in the second rectangle. What I mean is, the first sentence is a guide for HTML beginners is, you are seeing only this in the below rectangle, not the other lines like ahref, the double quotes, the URLs. All these are not seen because the browser knows what to display and what not to display. So hypertext markup language will tell the browser, display only the information I specify that you want to display, and rest of the things are instruction to how to display, like blue color, background information, bold, italic styles, and things like that. So it has a code to tell the browser how to display the data. It also has a code that is actually the data that will be displayed on the browser. So that's why it's called a markup language. It has both the information combined together. By default, HTTP uses port number 80 to send data from your browser out of your computer to the server where the information is stored. HTTPS, in HTTPS, S stands just for security. And HTTPS uses a different port. It can be either a 443 or 84443. What is the difference between HTTP and HTTPS? Any website that supports HTTP, when you log into that website, this is something that you need to keep in mind before logging into any website that is asking for your username and password. When you enter your password, it is transported to the server just in the way how you enter. So if you enter ABC123, it gets sent as ABC123. So any hacker who tries to interfere between your browser and the server can read your password. But in HTTPS, when you send ABC123, it gets encrypted and sent in some weird language. So even if someone tries to interpret, they will not be able to make any sense out of it, what you're trying to send. So any information that goes out of A4 8443 port or 443 port is always encrypted. So this is another example of how a typical web-based URL looks like. Your HTTPS stands for the security. Then the mail.google.com is actually the domain name or the DSN or the IP address. It translates into an IP address where the server is located. Then you have the kind of resource. Resource is what you are accessing. You want to bring back everything from your inbox, right? So inbox is your resource that you are accessing. Moving on to cloud computing. Cloud computing is actually the hot topic these days. Everything is cloud and everyone is moving to cloud, right? But what is actually happening there in cloud? We need to know this before we can actually understand how we are using this for real-time applications. So there are 4 different types. What is the on-premise, public cloud, private cloud, hybrid cloud? On-premise is something when I have everything inside my home or inside my company. I buy my server from somewhere, I install everything inside my home or inside my office, then that becomes on-premise. Protecting that server is my responsibility. So it's always hosted in my LAN. This is actually the traditional or how everyone does it. Like if you back in the day, if you walk into any place who owns a website or an application, they will have a server in a protected area within their building. But public cloud is actually hosted in internet, provide the cloud provider, maybe like Microsoft or Google or like Amazon. They might have a separate place where they have all their servers and machines and CPUs, and you access the servers through their IP address. So you are sitting somewhere and your servers are miles away from you. So that's why it's called a cloud, and it's public cloud because it's hosted in internet and it is available for access to anyone who has the username and password. Private cloud is a bit similar to on-premise, but it's actually a cloud, but it's created exclusively for you. So big companies and like banking sectors, like who wants to go for cloud, but they also want it to be secured. They either go for private cloud or they go for hybrid cloud. So in hybrid cloud, they can actually choose. They can say like 50% of data they will store in private cloud, which will be the sensitive data, and 50% of information will be, or applications will be stored on public cloud. The disadvantage of being on-premise is that if you are starting a new company, if you want to build all your servers, then you need to put a large amount of money from your side because you need to buy all your CPUs, all your servers, you build that, then hard disks and stuff you need to maintain. If it runs out of memory, then you need to keep purchasing more disks. You need to maintain it. You need a person to support it. You need to build the infrastructure and other buildings to support your server as well. So it involves a lot of cost from you and a big investment. But in public cloud, you don't need that because you can start with whatever you have. You can actually buy a very small server first. Then if traffic is more, if from 50 people using your app, if 10,000 people are using your app in next month, then traffic is more. So you can buy more CPU from public cloud based on the number of customers accessing your app. Then maybe in 6 months, your app is more popular and 1 lakh people are using your app, then you can actually buy even more CPU. So gradually you can increase rather than buying a server that will accommodate 1 lakh traffic today. But what if your app is not famous and only 50 to 100 people are using? You don't need that much CPU, right? Which means you are wasting your investment and cost. But in public cloud, you can slowly expand and it's very elastic as well. In a on-premise, everything is your responsibility. So if your server dies or your server is down, then suddenly services will not work. Imagine like walking into an ATM and you're not able to withdraw money. Then it's all your responsibility when someone calls you and says that, sir, your ATM network is not working. Then you need your team to be available 24/7 so that they can actually fix your servers. But in cloud, either public cloud or private cloud or hybrid cloud, there's always someone who is taking the responsibility. So Amazon or Google or Microsoft, they will give you a promise that they provide maximum availability, so your server is always running. Security risk, since it is on premise, you need to lock your building, you need to lock your servers, you need to prevent it from hack, or you need to prevent it from destruction. So it's all your responsibility. So more responsibility on your side. But again, public cloud, these days the cloud providers are coming with security compliance as well. So there are government dictated rules to how to protect your servers from security attack, so that the customer data are safe. So many of the cloud providers are actually agreeing to this these days. So you can just trust them, put your data and applications in cloud, and just relax. So we just saw the different types of cloud. Let's see, like, what are all the things offered by cloud, like services offered by cloud. When I mean service, like anything someone does for us is a service. Like when you go to a hotel, someone serves you food based on your order, like, so that's a service, right? So anything that is done for you by someone else is a service. So I would like to compare the three different famous services provided by cloud with the on-premise. In on-premise, in this diagram, anything that is in blue is managed by you. Anything that is in orange is managed by the cloud provider itself. So when you go on-premise, your application is the website or the software or the mobile app that you build. The data is the storage that you store, like maybe if it is a banking records or the medical records, whatever that your application use. And the runtime, middleware, operating system, any images, your servers, storage. If your data is more, your hard disk has to be more, networking speed, everything has to be managed by you. But there is a flavor called infrastructure as a service, where you can take ownership of the application. So if there is any problem in your application, like people are not able to log in, you're trying to access the URL and it is showing some error, right? Then that is your responsibility. The data that is stored by you, suddenly you lost some 100 people that you stored there. That's your responsibility. Operating system, you have Windows 10, you get an update, you need to patch it, you need to update it to a new software, then that's your responsibility. But anything with storage, like it runs out of hard disk, then you can actually call the cloud provider and then he will does it for you. And making sure that your service is connected 24/7 by a good internet is responsible by the cloud provider. So that is part of infrastructure as a service. What is the example? I'm not sure, like, if you guys have heard about Amazon Workspace. Let me give you an example now. Like now, the latest trend is that when you join an IT company, right, like they have to give you a computer to work on. Then came a tradition that they stopped giving computers, they started giving laptops, so that people can take it home and they can work from anywhere, right? Especially in situations like this. But now, even, how many laptops would we buy? Like people will switch jobs, they will leave office, so they have to surrender the laptop, then that has to be allocated for someone who is joining new. Now there is a new concept in cloud, that you can allocate a server to one person. So this is a computer installed on cloud, someone can access from anywhere. So you can access that from your home PC. If you have a laptop or a PC at home, you just log into the cloud PC, then that cloud PC will be on your office network. So it's more like, instead of giving you a CPU itself, which is a physical plastic box containing a server inside, they are giving a Windows machine or a Unix machine that is hosted in cloud. So this is in cloud. So wherever you go in the world, you can log into it as long as you have a laptop. And nowadays everyone has laptop and computers. So the companies are now finding this concept very easy, right? So that's one example of infrastructure as a service. Software as a service, this is something that you guys might have or definitely would have used. Nothing is your responsibility. Everything is responsibility of the cloud provider. You have an application that you have built and deployed over there. You can just access your software through browser, or you can download the software in your machine, but you just have to log into the cloud instance. So Microsoft Office 365 is the famous software as a service. So it is based on the subscription. If you pay for the subscription, you get a these days you don't get a license key. It's all you sign in using your Gmail ID or your Microsoft ID, then you pay your money for Office subscription, and then wherever you have signed in using that, you get a free or licensed usage of your Microsoft tools. So that includes Word, PowerPoint, whatever, right? All Office 365 tools. So these tools or softwares that are deployed on cloud, but you can still use it using browser from your machines. So without even, you don't even have to install Office or PowerPoint on your laptop. So the same applies to Google Dropbox, Google Apps, Dropbox, Salesforce, Adobe Photoshops. So these are some famous examples for software as service. Yeah, sorry. One point that I forgot to mention is that the one major advantage of the software as a service is that since the installation and everything is on cloud, you are provided with OneDrive access as well. So you can basically edit something through your browser, save the contents directly on cloud. So even if you have a very minimal machine or a laptop with small specifications, you can still work on it since since everything is on cloud and you're just running it as a client from your browser. The last one is actually platform as a service. Here, this is more like you build something, you create a website, you create a software, you need a place to install it. So you need a server to put it, right? So this should be a trusted server, which is available 24/7. Otherwise, like someone who is accessing in the midnight will run out of service. So that time you buy your service as a platform as a service. So you can manage only your application that you have installed and the data that the application use. Everything else other than that is managed by the cloud. So you can be peaceful and not worried about the availability at all. So we all saw about the trend, we saw about the cloud concept and things like that. What is actually happening in the real world? What is actually digital integration is about? This is actually the hot cake in the market that we talked about. Instead of listening to the definition about digital integration, let's pick a live example, a simple tool or application or a website that we all have been using so far, and that's a very beautiful example of digital integration. And we'll see, we'll try to understand, like then we will come to an conclusion what digital integration is about. We are going to talk about the website called Yatra. I'm pretty sure everyone would have used Yatra at least one time in your life. What Yatra actually does is that it allows you to book your tickets on multiple flights. You can very well go into Air India and book your tickets, but you can still go to Yatra and book Air India's tickets on Yatra, which means there is a communication happening between Yatra and Air India, right? So this is called integration. So you are integrating two different websites together. So these are not websites anymore. These are smarter than websites. So they are called web applications. So as a user, right, the Yatra needs to know for whom this ticket is purchased and who is purchasing the ticket. So these days, the identification service has moved even more beyond, right? We are not even logging into Yatra. You have multiple ways to do that, right? You can either log in using your email ID, you can either log in using your mobile number, or you can sign in with Facebook, or you can sign in with Google, right? There are options for that. So what happens is that Google will tell Yatra that I know this guy, he has signed into my account, and you can actually go ahead and give him a ticket, right? So advantage is that you are not giving your Gmail username and password to Yatra. You are giving your Gmail username and password to Gmail, but Gmail talks to Yatra and tells that I know this guy. So there is an interaction between Gmail and Facebook to Yatra to authenticate that this is you. And you are also, when you are paying Yatra, Yatra doesn't have to give you his account number or IFSC code for you to transfer money, right? You rely upon external payment services like Amex or MasterCard or your Visa credit card or a debit card or PayPal or even net banking. So you give your net banking or credit card details to the payment services, not to Yatra, and still the money gets transferred by the payment services into Yatra. So there's this whole lot of integration happening between different services all across the web. You can still purchase insurance services as well. This is actually digital integration in the world, like, because we have developed so much of applications in the past 20-30 years. Every business, every company has its own websites, they have their own softwares to do business. But what needs to know what needs to happen in this world is that everything has to be connected with each other, right? So that's why actually we have digital integration here. The big advantage here is that Yatra promotes business for all of these customers who are tied out here, and also for the user. As a user, you can actually see different pricing of the tickets. You can compare them with each other. You can choose the cheapest one, or you can choose the one with minimum stoppage, like you don't want to stop at 2 different places to reach a third place. So it's up to you to choose what ticket you want and which airways you want. So you don't have to go to 5 different websites to do that. You can sit at one place and you can do that. So you have the internet has integrated all these services together for the betterment of the user, right? There are actually multiple tools in the market currently. Each of them have their own workflow. We're just going to go across some of the examples that I could think of. Book My Show, Redbus, Make My Trip, Hotels, Zomato. You might have seen or used at least 2 or 3 of these apps in your life. All these are actually examples of digital integration. All these applications and web apps are deployed to cloud. They have their own cloud server, and each of these applications are talking to each other. And the way that is binding all these together is called interfaces or APIs. So that's why we are going to see more about APIs and how you are going to tie this application one to another. So like you saw in the previous example, APIs are everywhere. Like when you use a smartwatch, your Apple Watch or your Fitbit watch, you live stream anything in your TV, Netflix, Prime Videos. Even the cars are having smart apps these days. Your mobile phone has plenty of smart applications these days. Your laptop, of course, it has many applications, website, you might go into online banking. Everything is talking to some application that is deployed in cloud, and it is exchanging information to something that is there in internet, right? So the medium how the data is shared through the internet is called web APIs or web services, right? So we write web APIs to connect one application to another application, and the data is exchanged between them in the format either JSON or XML. These two are the famous data exchange formats. So there's quite a few plus and minus between JSON and XML. JSON is the new in the market. XML has been used for the long time, but it all comes down to what the programmer and the technical architect team desires. Like there's no big go around among these two. So when I say API, in the real world, like for non-technical people, it's API, but for us, to programmers, it's actually a HTTP endpoint, right? Like it's another URL in a browser, because APIs are deployed in internet. It's somewhere sitting in someone's cloud server. So if it is sitting in a server, every server has an IP address, every server has a URL. So to access something through a URL, you need a HTTP endpoint. So when you see a HTTP web service, it's called a REST web service. That's the new naming that is being used for the HTTP endpoints. So a client app or a browser or your mobile phone, whatever that needs an information, it actually sends a HTTP request to an API that is sitting into the cloud. Then that brings back the information from the server, either in a JSON format or in an XML format. So you have multiple HTTP actions. You must have studied in your school days or in your initial first year or first semester or second semester about the HTTP actions: get, post, put, and delete. It's all quite similar here. It's the same thing here. So I have given some examples of how it will look like in the previous Yatra example we saw. So to get some information about the flights for a particular day, say 22nd of July, then the URL looks like this. And the action is a get. To send a booking request, the action is a post. Then the URL looks like the one below. To modify and the booking, like for example, you have booked a ticket for 22nd, but you want to change it to 23rd, then you send an update. Then your URL looks like a put. If you want to delete an address that you have added, you might have added through 3 address at the Yatra, you want to delete one, then you send a delete. When you click the delete button, the browser sends the delete request. So the URL looks like this. So it all comes down, I'm talking from the programming perspective actually. And so how can I create this URL? How can I create the endpoints, right? So you can do it using Java or Python or ASP.NET, Node.js, PHP, C#, or Java Spring Boot, Apache Camel, and Spring Boot and Apache Camel are the trending topics these days. So if any final year guys or final year students, like you're preparing for projects, or if it is too late, then for the third year students, I would say, like, if you try to explore more into Spring Boot and Apache Camel, it's going to be a worthy learning for you all. This security. So this is the most important part of when you're going to write a program that or software that's going to be running in the digital integration space, because there's quite a lot of threats and security risks around us, and you have to keep thinking about innovative ideas how to keep yourself secure, right? There are multiple security methods in the market, but I'm going to picturize them rather than giving definitions, so that you can actually relate to what you have seen in your life so far. Two-factor authentication, OTP. You try to log into your online bank, it sends a OTP. You try to log into any website, it gives a OTP request to your mobile. Then you enter the OTP, then it lets you log in. This is called two-factor authentication. Credentials. This is the traditional one. You enter your username, you enter your password, it lets you in. Biometrics. This is a device connected to USB in a laptop, maybe. You enter your thumbprints or your fingerprint to any finger, then it lets you in, it identifies you. Security token. This some of you might have seen a few banking customers having this. They send this device to your home. When you press the button on the device, it will generate 16-digit number. Then you enter the 16-digit number along with your password, then it lets you in. CAPTCHAs. You might have seen this when you made a mistake while entering passwords in Facebook. It just makes sure that you're human and you're not hacking from software. So these are all application level security, right? To make sure that only a human tries to enter and only the right human tries to enter, not a software or a hacker tries to log in. But other than logging in, while sending data also, you need to be very careful, because during transport someone can actually intercept and try to hack the information. So there are multiple methods like Kerberos. Kerberos is a way that two servers they identify each other, that they are the right persons talking, so that if the third server, which may be a hacker's machine, who tries to send the same data, then the server neglects any information from that server. SSL, which is the same HTTPS we saw. Whenever you go to a bank website or a Facebook, anything that has HTTPS, if you go to the top left corner in the browser, you can see a green lock symbol, so which is SSL secured, which means that anything that goes out of your computer is encrypted, so no one can read and identify what you are sending. VPN, you guys might have used VPN in your laptops and your mobile device now. It takes you to a completely different private network, so that the server will not trust your internet. It will say, switch on the VPN, come to my network, let's talk, because it trusts its network. So VPNs are very much helpful in this field. So when it comes to security, right, like now, so far we have seen only about authentication. What is difference between authentication and authorization, right? Authentication means ability to identify it is you, right? If anyone else goes other than you to the bank should not let them withdraw money from your account, right? That's authentication. Authorization is actually giving access to the information. It's more like when you try to take an online quiz, or online when you try to access any forward emails, right? Like, then you are giving consent that that this particular website can access my information. So that is the authorization. So then they can actually access only your limited information, like your name, your address, your email. That's it, nothing anymore. So that's authorization. So OAuth is actually authorization. It's not just authentication, it's authorization and authentication both. We will see with an example, right? Then you guys will understand like what I'm talking about. What is authorization with a real world example. Imagine there is a web page called photo printer, right? It's an imaginary website. It might be there in the market as well. So what this guy does is that when you upload photos into this website, it has the ability to print these photos and send it to your home, so that you can decorate your home with the converting that into fitting that into a frame, and then you can actually decorate your living room, right? You can also allow the photo printer to access the photos that you have stored in Facebook or in your Google Drive, right? So to do that, you are going to photo printer and you are asking, can you please print my photos and send it to my home? Photo printer will say, but I need an authentication. So I need to know who you are, right? So now this is where you go to Facebook. Photo printer needs an auth code, please. You are requesting that. So this is where photo printer shows you the option that we saw in the previous slide, the sign in with Facebook and sign in with Google, which you see whenever you go to Yatra or Book My Show. You can actually sign in with Google instead, even in LinkedIn, I guess. So you are thrown back with a login screen from Facebook or from Gmail. You enter your username and password, which is your Gmail ID and password, or Facebook ID and password. You click on login and authorize. So this is the trick here. You are logging in, which is authentication. You are authorizing, which means you are letting photo printer to access specific information from your Facebook profile, which is your photos from your Facebook, your name, and possibly your address, your phone number, and that's it, not your friend list. So you can restrict the information that can be accessed by photo printer, which is called authorization. Since you have logged in, Facebook knows it is you, so it is able to identify you, so it gives back your authentication code. So you provide that authentication code to the photo printer. Now, what has photo printer achieved? Photo printer knows your name, you have logged into Facebook, and you are a real person and you're not a hacker. Now photo printer needs to prove Facebook that he is real and he actually talked to you and he's not a fake software. So photo printer goes to Facebook and says, listen, I spoke to this user now. He signed in using your Facebook URL and he's a valid user and he gave me the auth code. Can you please give me an access token? And Facebook replies back, okay, I know this guy. He just logged in now recently and I remember the auth code too. And here is the access token. Then photo printer gives the access token back and says, I need the picture number 10. Then Facebook identifies, okay, you have the proper access token, you have the proper auth code, and I know who this details belongs to, and you can actually now take the picture back. So Facebook gives the picture back. Now photo printer has the picture and it can actually print it and send it to your advice. These are the steps that happens whenever you go to a website and press sign in with Google, sign in with Facebook. This is OAuth. You are all using OAuth in your daily life every day without realizing that it is OAuth, right? And this particular steps that you carry out till you get the resource back is called OAuth dance. We are almost towards the end of this presentation. We've seen about digital integration. We saw it with a real-time example, how there are many apps floating around us with implementing digital integration in this space, and also how the security mechanisms, the recent trends, and how we are actually using it as in our daily life. And this is perhaps the most crucial one, like when a customer approaches a company and says, I need a digital integration platform where I want to integrate 3 or 4 business together and I want to do business together. Something like a Zomato where people can order, or Uber Eats, something like that. Then they need to do a technical architect design. This is how a technical architect design would look like. The things on the top end are the users who will be using these services. So it could be a web portal where people will join through a browser from a computer, or it could be a mobile application, or it could be maybe a content management system where a specific software is consuming all this. Then at the bottom end, you have the resource providers. I've just collected some of the famous stuff like a database service like a MySQL or a SFTP where you will have files. JMS is a messaging system. Gmail, where you can access your emails and inbox and services. Salesforce, where Salesforce is a software where it's a CRM software, customer relationship software, like where you can actually have details about your customers and your products and invoices and stuff like that, where you can monitor your business. So basically everything that is there at the bottom are information providers. So if you correlate with the Yatra system that you saw, all your Emirates, Air India, all these are information providers because they provide the tickets. So they will come to the bottom of this slide, and all the users who use like Autho mobile app, Autho through a website, ticketing agent who books tickets for you, everyone comes to the top, right? And system APIs are the APIs that directly talk to the external systems. So there will be system API for Emirates, there will be system API for for Air India and stuff like that, because they are the different targets for payment system, for your insurance services, for your login services. There will be specific system APIs. So whenever you get into a digital integration project, you actually first visualize what are all the target system you are going to connect. So then you create that many number of system APIs for your target systems, because these are connectors to the outside world. You create one or more URLs based on what information you need to get or send to these target systems. Then comes the process API, which is one level top. A process API will always communicate to the outside world through the system API. They won't call the Emirates web service directly. Process API will always be targeted towards a business process. For example, booking an Emirates ticket is for booking a ticket. It's not that simple, right? Like you have to enter all your details, your name, age. If you're older than a specific age, you get a particular discount. Then if you are a child, then you are charged in a separate manner because you are charged basic rates. So these are all business processes. Like these are all workflows or set of rules. So all these implementations are done inside process API layer, so that system API layer will do nothing other than send and receive information. No logics or no brilliance goes into this layer. Experience APIs layers are actually even more higher. So any external system will mostly communicate your website through the experience API layer. So these are like the system APIs talk to the outside world. Experience API are gateway for outside world traffic to come inside your system, right? So that mobile APIs can call you, so that your website when you load yatra.com, then that comes through the experience APIs. This DevOps, it's good to learn like how and what DevOps is practiced, but this might be one of the last slides I have, and might be a bit more complex, but I think this is another revolutionized topic actually currently, because DevOps has increased the speed with which we are delivering things to the client. Imagine like a team might be having 10 different people, and they might be sometimes they might be working in the different requirements, but maybe same class. For example, there is a Java class and two developers are fixing it. He might be writing a method A, and then the second developer writing might be method B. What if the second developer corrupts the code of first developer? We don't want both the developers to overwrite each other code, right? Like then that case, the code might be lost. So to protect that, we have something called version control. So that's where all these three developers directly work on this server, which is called version control. This server makes sure that everything that every developer develops is always up to date and the code is not lost. And always the code is taken from the version control, not directly from the developer's computer. And there are tools and plugins now these days which will deploy these servers automatically, I mean this code automatically into different servers, like either for testing environment, for client testing environment, UAT, whatever. So there are different providers for version control. SVN was days in the past, and Git is actually moving on quite now. So I would actually recommend guys who are actually trying to build something for your college or for your project work, try and explore something about Git and GitLab. Actually try to check in your code into GitLab, because that will give you a bit more exposure before you step into IT industry. And guys just don't code these days, they also test. And you might have learned something about unit tests. Unit tests are more like another code that you write which will test your actual program itself. So any developer, when he's given a requirement, say okay, write a method test that is going to do this, then he has to write that code. He also has to write a unit test. That's how every developer works these days, so that the unit test will test the code, and only when the unit test has passed, his code will be taken to further steps to be integrated and to be considered delivered. If the code is not unit tested, or if the code has not cleared any unit test, then the code, I mean, literally you cannot say that you have completed your code. So there are few processes that you can actually clear, and this is all automated, so that everything that you run is always tested, and it is only tested code is deployed to the production. I think we have reached to the reached the end of this session. I think I have covered right from the start how the IT company looks like, what type of business we do, how a procurement happens, how we bring business into the company, what is the latest trend, what's happening around you, how you approach things as a solution, and the development models and in and out actually. I think it's best to give some time for the questions to fly around. Are you there, ma'am? How are we going to handle the questions now? Are we going to take it up from the students directly?
So the faculty members will be asking you the question now.
Sorry, can you say that one more time?
Hello, sir.
Yeah, we can give 10 to 15 minutes for question session, sir.
Yes, sir. Yeah, we can just wait for the question, sir. I have got one question, sir, from an anonymous participant.
Okay.
Sir, how a fresher can get projects for his or her startup? Is there any chance through getting it by online?
Yes, actually, that's actually a good question, because when it comes to companies and clients allocating projects to other companies, right? Like they always, most of the time they go by the brand. So I would say that if you are actually want to do it, you can actually do it two ways. Like you can do it as an individual developer, then you are called as a freelancer. So you need to register into many freelancer websites. There are a number of famous ones in market actually. So you need to register yourself, you need to prove yourself, and then validate your PayPal account. And there are some background reviews and checks, I guess. You need to build your profile, build more sample contents, provide more information about you, resumes, accolades, and things, because the company will definitely like to see what you have done in the past. If you are a starter, then I would say that you should spend more time at home building applications and demos. It's more like building your profile, what a designer or a Photoshop designer would do. Then that becomes your templates, which you can actually showcase to undertake more customers. But if you want to do it professionally, then you need to register yourself as a company. Then you need to, like I said, like the sales team has different approach, sir, these days, based on how the marketing is done. So they sometimes they arrange these technical shows, right? Like they go for workshops, they meet new customers, they advertise them, they create their brand and showcase them. So that's one way to attract more customers and clients. Or you can actually go on search in internet and look for companies that are advertising for the requirement that they have, because some companies will invite bidders for with a quotation in hand.
Okay, sir. So that's another question from Selvam, sir.
Yes, sir.
Where we use HTTP and where we use HTTPS?
Yes, that's a very good question, actually. We saw the benefit of HTTP and HTTPS, right? So whenever you're going to hold any sensitive data about the customers, whenever you are going to let anyone log into your website, then always you need to use HTTPS. HTTP is more like a static website where you go and see. It's more like if you want to build a website about your resume, right? Like, or your company, where you don't want to bother anyone signing in or because you're not, they're not the employee. They just want to come read your company profile and see what type of business. And this is a static website that you're building, maybe in a WordPress or anywhere. So then that has to be, that can be HTTP, because there's no harm in doing that.
Okay, sir, there's a question from another participant, Manju Bhargavi.
Yes, sir.
How hackers hacking data even in SSL security?
Well, yeah, that's a that's a sensitive topic, isn't it? We can there are quite a few topics about ethical hacking, but I think we don't want to go overly into how people are actually accessing hacking here. But I think cookies is another way. They try to get information about people, and keeping the passwords and OTP secured. Like we saw that we did see that there was a two-factor authentication, isn't it, as one of the security measures. So always we need to enable that. The most of the hackers, they always search for vulnerabilities. Like if there is anything that you have not noticed or you have left carelessly, then that becomes a perfect place for them to exploit.
Yes, sir, that's another question from Selvam. In
Yes.
cloud, who is responsible for security? Customers or cloud?
I would say like 90% cloud providers, 10% comes to you in keeping things safer.
Yes, sir. Thank you.
All the cloud providers have security compliance, so they will try their best to not disclose the server details and the server access, but keeping the access intact is upon the individual responsibility.
Sir, sir, can you explain a challenging project that Integrella came across so far, sir?
Yes, sure. Actually, we have come across quite a few so far. We have dealt with data migration in the past, where we had to migrate data from legacy application into the new one, because they were actually purchasing a new software itself. We have done a digital integration for a couple of hospitals here in UK, where we have connected the main hospital software with the labs and other systems. So it's all automated now. So when a patient arrives, he can get registered, sent to a doctor. The doctor checks him, orders him a test, maybe an X-ray or a blood test, and then the results comes back. So everything is software automated, and then the doctor can check everything in a computer. So you don't have to see papers flying around here and there. So it was a massive application. It took a year to do, but yeah, that I would say, like, yeah, those were a couple of the things that we did, and we quite enjoyed it.
Thank you, sir. Thank you.
Hello, sir. There is one more question.
Yeah.
API from web services. Is there any additional advantages for using it?
Sorry, please say it again, sir.
So why REST API from web services? Is there any additional advantage?
REST API is a web service, sir. REST API is a type of web service. There are two types of web service: SOAP and REST. Right? SOAP is actually a thing of the past. They are using REST more because there are many advantages. I would say REST is more lightweight. SOAP is more like you need to create a web service, then you need to pack it into a WSDL, then you need to give the WSDL to the people who are going to call your web service. They have to digest the WSDL. What happens is that sometimes you might have 10 or 20 web service inside that WSDL. The customer may not need to have access to everything, but in REST you don't have to give a WSDL and all. Like, you create your endpoints and you can write the documentation about what all methods, like if you're accessing your inbox in Gmail, in the URL we saw, you put a slash and you type inbox, you access your inbox. you can just say that to your customer. You can say that you use my domain name, put a slash and write inbox there, then you will access the inbox. And he doesn't have to know what all keywords combinations he can use in that URL. So you can provide only the information what you want to access, and plus rest is supporting JSON. Like everyone is preferring JSON these days because it's more, again, it's more lightweight and easy typed compared to XML, where SOAP is strictly XML.
Okay, sir. Okay, thank you, sir. There's another question from another user.
Yes,
What is the foremost thing that a startup should initiate for acquiring project for his software company?
right. Yeah, there is a balance here, right? Like, do you have to have the team before you get the project, or do you have the project and get the team, right? But there should be a good balance between that. You have to have a minimalistic team first to get the project. You need to make your mind where you are actually going to acquire the project. There are many fields, many technologies, right? Your technical architect or your higher level technical team can be a multi-skilled person. Then you have a core team which have at least 2 different sets of skills. Then that actually forms your minimalistic team. When you have the minimalistic team, then you actually have the confidence to impress the customers that you have actually the team on board. Then what happens most of the companies is that during the idle time, they actually spend that time to build on example projects. Like it's all in, they call it internal works. So they work on internal works, they build all those, and they provide that as a showcasing element. So when a customer comes and says, what have you done so far, they show all these internal projects to them and say that this is the similar style of technology we will apply for your tool also. So for someone who specializes in online booking, then you create multiple online booking softwares, internal projects. Then you have them as a showcasing element for anyone to come on board. Then they get impressed with the latest technologies, latest style, latest database that you have developed. Then they actually select you as a company actually. Then based on the size of the project, then you can actually increase in the future. Like you can get 2 more people on board, you can hire, you can move into different technologies in future.
Okay, sir. Thank you so much, sir. Another question: is Bitcoin legal, or it can or it can become legalized in India?
That's I think that's beyond my expertise to answer to that. It's legal in few parts of the world actually, but yeah, if I have to answer, I have no interest in Bitcoin.
Okay, sir. Thank you so much.
Thanks for the valuable webinar, sir. Next, it's time for the vote of thanks, and it will be delivered by Mr. L.S. Vignesh, the coordinator of this webinar. Sir.
Happy evening, everybody. This was such an impressive session from Mr. Arun. He nailed it actually. I thank him for his wonderful intact section on behalf of our esteemed secretary and joint secretary. I thank our honorable principal, Dr. C. Madhalai Sundaram, for his wonderful guidance. And I thank our vice principals, Dr. A. Soleraj, Mr. N. Madhavan, and the placement officer, Mrs. Archana, for their incredible support. I also thank our head of the department on his direction towards a successful completion, along with the technical support team. And last but not least, I thank my dearest colleagues and the smartest students from all over the state. Thank you. Thank you, sir.
Thank you very much, everyone.